Hello everyone and welcome back to this part 3 in the series Functional Reactive Programming in Angular. For the recap, we have built our to-dos application using reactive programming with CRUD operations, leveraging effective usage of RxJS operators, ensuring that it is declarative and self-contained, extensible in its own way. For example, our actions, our events, and our API calls, and of course, the data selectors, each having its own responsibility and meaning, which we extend or chain together to support the whole application or the business entity functionality. This time, we are going to take it one level up because when it comes to applying concepts to support real enterprise big scale application, we need to give extra attention to the aspects like scalability, ease of use to support the dynamic team, extensibility, and providing a framework which could enhance robustness. Hence, when it comes to reactive programming in Angular, how can we not discuss about this amazing library called RxAngular slash RxState? Let's have a look. Whenever it comes to local state management, my go-to solution is RxAngular State. It offers a lightweight and intuitive API, hence less learning curve. You'll see soon with automatic subscription handling and performance tuning out of the box, making it a perfect solution for handling state in your Angular component, service, or directive. I'm not going to dive further, but if you want to learn from the very scratch and learn the ideology and motivation behind it, please have a look at this video here. Trust me, it's very easy to follow and informative. Without further delay, let's go ahead and install it in our application. According to the version compatibility, since we are on Angular version 16, we'll be installing its 16th version. Although 17 is also available now, it's not just updated in the documentation yet. Uh, okay, for this, let's go to installation, copy this particular command, and add at the rate 16 at the end. Since I already have it installed, I'm not going to run this command here again. But for your reference, this is what you need to run for installing it in your application. Okay, after installing it, go to your to-do service where we are handling the to-do state so that our component doesn't have to do the heavy computation and manage the state, and it could be minimal and thin as possible. We have already laid down the foundation for a declarative and reactive system, but here we are going to simplify it further. So for that, we will not going to be needing these two things anymore. Okay, let's get rid of it. And all we need to do is, so before going ahead, there are three ways how you can create the Rx state in your application. Let's go ahead and again in the documentation. So first way is functional creation, wherein you just call this particular function and do your things. This is what we are gonna use for our case, since I feel it's the cleanest approach here. Again, my personal preference. But if you want to use the class-based solution, that is also there. For that, you just have to provide it locally to your component or service like this using inject or constructor based injection, or you can extend it in your component or service or directive like this. Cool. Let's go ahead with this particular approach where we are calling this rx state function from RxAngular state. Okay, so let's define the state and call this rx state. This will be imported from RxAngular state, and here you can pass a function where you'll be getting its utility functions, like I'll show you from IntelliSense, like connect, get, select, set, or set accumulator. You can read more about these utilities again in the documentation, but for our use case we are gonna use only connect. But just as a side bonus, this particular function, the set, right, helps you set the initial state for your component or your service. Okay, we are going to use connect, so let's have it here. And also you can provide a type definition here, wait a second, where you could say how your state is going to look like. For our use case, we are going to have this to do list of type I to do. Okay, there are two syntaxes we will be following for this connect. The first syntax is connect, and it says which particular slice. For us, the only slice we have is to do, to maintain. You could connect your observable, so whatever your observable returns will be set to this particular slice. And for us, the initial to do's, whatever it's going to fetch us, will be set to inside this to do's, right? Good enough. And for further cases, whenever we do update, delete, or add, or mark as completed, and we already have events for that, we are going to utilize the same events. So we say we already have the observables for it defined already. So what we are going to say is, again using the connect this particular observable, again to manipulate or to set this particular slice itself, that is to do's. Let's start with to do added. Cool. Here I'm gonna pass a callback function, right, which takes two argument, that is old state and the current value that this observable emitted. So this observable emits the to do, the new to do item that is supposed to be added. And as of now it is showing a warning because we need to return the modified list here, because we are going to set this to do's that is of type I to do, this list of I to do, right? So if I return something like this, see, the warning goes away. But if any to do is added, again we can utilize our utility method which we defined earlier, this on added. Although, yeah, just see the syntax and we are going to follow the same approach. So for this dot to do added, wait a second, on added, here we have to pass the new to do, and here we have to pass the existing to do. Existing to do is in the old state, dot to do's. Cool, good enough. We have defined our initial to do's from this particular observables, and whenever this to do added observable emits, in the previous video I have already showed how did we create or make this particular observable out of to do action and the API call afterwards. So let's go ahead and try if it's working or not. But for that we have to expose again a to do's observable, right? So how we are going to do that is to do's observable equal to this dot state. Now see, you're going to see in a moment what and all it exposes, this particular state dot. This exposes a lot of things, but for our use case we are going to use the select, and here I'm going to pass the slice what I want, and it is giving in the auto suggestion also, since I have my state definition declared or defined here. And that's it, done. Let me try to use this to do in my component now. I have to replace the existing latest to do's here. And that's it. I am done. Okay, let's try to refresh this. Okay, it's not working because I didn't run my application yet. Npm start. Okay, my application is running. Let's try to refresh it. Okay, so this is my first get API request to fetch my to-dos, the existing to-dos. It's working as we expected here. Yeah, now let's try to add something. Let's say item, yeah, it's added and it's calling its post API call here again. Cool, and it's showing up in the UI also. So our add is working. So in a similar way, we are going to add the update, delete, and mark as completed state also. Connect again for this to-do slice, which observable. Let's support deleted, to-do deleted. Whenever this observable emits, we are going to get the old state and the value, that is this to-do that is supposed to be deleted. And also we can follow this shorthand where we can spread the old state to-dos. Return this dot on deleted, the to-do that is supposed to be deleted, and the existing to-dos, that is nothing but this. Cool. Following the same pattern for to-dos updated, this dot to updated, and returning the updated list using the utility function for on updated to do and the existing to dos. Now we are supporting the deleted, updated. Let's support the mark as completed. This dot to do completed. Following the same syntax, the existing to dos and this completed to do. Returning the modified list for this on completed, passing the completed to do, existing to dos, and we are done. I'm supporting all the operations here in a much more understandable and clean way. Let me try to save it and show you if it's working or not. Okay, this is the initial get request, and let's try to delete something, this item 5. Okay, it is doing the delete request and it is deleting it from the UI as well. Let's try to add a new to do. Let's say item 6. Yeah, it adds it. Let me try to update something, item 6 to item something. Yeah, it updates also, marking this as completed, marking this as completed, doing the API calls accordingly. And yeah, it is working as expected. Also, there is one more thing. Now this particular library supports signals also, and in a way, as you saw that it gives us the observable for our to-dos, you can also get the signal out of it. How? Let's show you that. To-do signal, this dot state dot, see, it has this method for signal, and you give for which slice you want to expose the signal. Okay, in my component I'll use this to do signal. Let me comment this and have to do's signal from my service. To do service dot to do signal. Okay, and let me call it inside of my template. Yeah, save all the changes and test if the things are working as expected or not. Let me mark this item 4 as completed. Okay, it is working. And let me try to delete this item 3. Yes, that is also working. Let me try to add something. Reading, save. Yeah, it's added. And yes, everything is working as expected. In summary, this time we leveraged this library called RxAngular state for managing our to-dos throughout its life cycle, following the same reactive paradigm, simplifying our solution and making it more scalable and extensible. I would urge you to go ahead and start using the same strategies and concepts into your application and see the difference for yourself. Thanks for watching. See you in the next video. Stay tuned.